Hello, today we will discuss about X-ray spectroscopy. We are all aware about the medical applications of X-rays. We will now discuss about the use of X-rays in analytical chemistry. So X-rays can be used as a very valuable tool in analytical instrumentation. So it has X-rays when they interact with matter, they undergo absorption, the properties absorption, there is fluorescence, there is diffraction as well as scattering. So all these find use except for scattering, all the rest of the three find use in analytical studies. So we are aware how X-rays are generated. It's by bombarding a target with electrons, or you could have secondary emissions, or radioactive decay results in X-rays. It can even be generated from a synchrotron radiation source. It's a high energy source. So this is the process what happens. So bombarding the electrons on the from the cathode to the anode will result in electrons being emitted from the inner shells, and this inner shells will be filled by vacancies, or will be filled by electrons from the higher energy levels. So along with this de-excitation, energy is emitted in the form of X-rays. So there could be two possibilities. One is a continuous spectra, other one is a line spectra. So continuous spectra is caused by interaction of this electrons which are impacting on the anode with the nuclei of the anode. So the target anode nuclei will repel these electrons. So as a result, the kinetic energy of these electrons will be reduced. So reduction in this kinetic energy is emitted as a photon, X-ray photon, and this is a braking action on this, the retarding action on this electrons. So this is called as Bremsstrahlung radiation or the continuous radiation. It's a continuous spectra. So this is a continuous spectra of Bremsstrahlung radiation. Then there is a line spectra which is characteristic. So line spectra is caused by the transition of electrons from the higher shells to a lower shell. So the resultant emission of X-rays. So there is K alpha and K beta corresponding to transitions to the K shell from shell 2 as well as shell 3 respectively. Similarly, there is L alpha, L beta, similar like that. So you have the continuous spectra and the line spectra, which is otherwise called as the characteristic X-rays. So we already discussed emission, how X-rays are produced. There is absorption property. So we have X-ray absorption spectroscopy. So X-ray absorption spectroscopy basically relies on the fact that each element will absorb a particular amount of X-ray depending upon its atomic number. So this is causing the absorption of X-rays will cause excitation of electrons of the inner shells. So there will be a very characteristic peak as shown in this jagged edges here, as shown in this sawtooth like edges. For each element it will be a characteristic peak. So there is an absorption peak for lead and silver. So it's based on the Beer-Lambert's law. Beer's law. So you have the powers of the incident as well as transmitted beams, and you have a absorption coefficient. So now this is X-ray absorption spectroscopy. There is also fluorescence. Fluorescence is caused by de-excitation of say the ion to its ground state with the resultant emission of X-rays. So this is fluorescence. Fluorescence is also a very characteristic property of elements, and this is X-ray fluorescence spectroscopy. So this is finding use in X-ray fluorescence spectroscopy. Diffraction of X-rays. So like all electromagnetic radiation, X-ray when they are interacting with the crystal lattice, it will undergo diffraction, because the lattice is a very ordered structure. So that will lead to constructive and destructive interference, and which are characteristic of each crystal. So this is the basis of crystallographic studies, X-ray based crystallographic studies. Diffraction, XRD, X-ray diffraction studies it's a very valuable tool to characterize material. So we'll discuss XRD in the subsequent section. I have included a material in this in the classroom. Do refer it. So this is the spectroscopy instrumentation. There will be a X-ray source and the collimating arrangement to get a narrow beam. Then there will be what do you say? It will be, the collimator is usually metallic plates, fin-like structures. And then there is a monochromator. Monochromator arrangement is to get a narrow beam of X-rays. So this you read the details from standard sources or references. So this is basically the X-ray